So it's been there for a long time, and we are doing this hardware manufacturing over the, we could say almost 5 decades probably. So it's evolved like from a single transistor to million, zillion transistors in a given space, right? So we had long before we had processors with minimal memory constraints and data width and all those things. Then we added the parallelism by adding more transistors, and then powerful core became the highest of the parallelism. Then we started adding more core to a processor itself. So it became like quad core, and then now we have odd core and everything. Then we didn't stop there, and we started adding more CPUs, which means we started adding more processor to the system itself. So we are doing pretty much how far we can do for the horizontal scaling and all those things. So have you ever wonder, like, since the Moore's law itself talks about a physical unit of space and all those things, there will be a limitation, obviously, right? Obviously, right? So maybe not today, but eventually it's going to end up having so much transistor in a space which you can't even do this. So we'll pause here, and we'll talk about a different topic out of this track. So how many of you are aware of quantum tunneling and all those things? Okay, don't worry. Even I was not very much familiar. I just did a research in. I was just refreshing, and then I found that the quantum tunneling. Maybe all of us who have read about the diodes, transistor, and everything, right? Transistors are basically, let's say switch. Okay, if you supply power, it goes on and off. The NPN transistor, depletion layer, and all those things, EDC stuffs. Anyway, we'll go from there. It's a switch, and it controls the data flow in the processor, which means when the switch is on, it takes the binaries and all those things. That's how that's how the actual processor are processing data. So in that sense, quantum tunneling is all about how do I say? So the electron movement between two lines, right? From let's say transistor, there is a region N and P, and the power supply is been supplied. The electrons are forced to go other side. So the depletion layer forms. Okay. So the quantum tunneling talks about if the depletion layer is very thin enough, the layer is very thin enough, the electrons eventually end up in being the other side of the transistor, so, or the other side of the wall. Not just in transistor, it is a common fact they are talking about. So when we have this Moore's, coming back to this Moore's law, when we have so many transistors with the minimum size, let's say, actually we are dealing with nanoscales. Let's say even we are minimizing the size of the transistor. Eventually, what we'll do is like there will be a pretty much in the N section, pretty much will be end up only having N molecules or N electrons. So you don't have a space to movement of the electron so that it can reach to the other side, or even the depletion layer cannot be formed when there is a very cramped space or something. So eventually where we are ending up is like this transistor will malfunction. So eventually we can't increase the number of transistors in a given space. So that's how we could say probably the Moore's law is failing, or it's going to be failed. That's the theory. Okay, now we have we understood why we talked about quantum tunneling, and we are still on track. Anyone have any questions so far? Okay, so the free lunch is over is a famous paper. Is talked about concurrency and all those things. So what it does say is like, we have been programming a lot of decades, say 50 years. We talked about, as a programmer, we had a luxury of doing whatever we want because we have a parallelism in place. If you want to increase your throughput or something, somehow you can add some more processor or vertical or horizontal. However, you can scale and does this. Those things take care of most of the heavy lifting or something like that. I'm not saying that's the only one part as a programming world did, but still, we took a advantage all those hardware evolution and everything. Assume that there is no more hardware evolution, so what we're gonna do sometimes later then? So obviously we have to handle everything in software, right? we hope it's a long way to go. Yeah, but we are not preparing here, but this paper talks about, even we have a OOPS and other paradigms of programming, the concurrency, it should be a core part of programming, and how do you have to handle the concurrency and everything. So even I, misplaced a word instead of concurrency in parallelism when I started the talk, I believe. So do you guys, college we have really had so many talk about parallelism and concurrency and all those things, right? So probably end of this session, you'll definitely have a brief idea about what is actually parallelism, what is actually concurrency, and both of them not same, okay? I can assure you that with that. Okay, so before starting Go, we understood that we have a duty to get started with something called concurrency, because we cannot do so much parallelism in terms of hardware, hardware stuffs and all those things. Okay, so this talk about is as I mentioned, let's get into the actual talk now. So it is about a Go programming languages. It's going to be very simple. So what is Go is like? It is an open sourced programming languages by Google, and it is a BSD license. Again, like it's a restricted, kind of a restricted license. And then Go is a compile language, like C, C++, it is actually a compile language. So when you compile to you usually compile to a native binary of that platform. So Go is also statically typed. So all of you are aware, like statically typed is like you have to, the system can infer the type, but you have to mention the compiler that this particular variables or types are going to have only certain type of data. Okay, so Go is known for its ecosystem, so because it has a rich toolings and standard libraries on its own. Okay, especially, and also it has a standard documentation itself. The only one resource you have to look up for every other problem that you have in terms of Go development itself. Okay, and again, it's an opinionated. So like probably any programming language, if we go and talk, the only first two questions that will be like, is it a OOPS, or is it a functional programming, or what is? That's a usual case. So in my perspective, like it's neither OOPS or nor functional programming, but it's a more of a procedural languages. So it is a you can say, like in general sense, it is an advanced C is the best analogy I can give you now. So, but still it accommodate both functional programming concept as well as the OOPS concept. You can still do pretty much most of the OOPS concept in this Go actually. So also you can do a programming, functional programming stuffs as well. So it is, it can do both. So next to the next point is like, it's a memory safe. Unlike C, we don't manipulate the memory here, but still we do have a pointers in Go language. So those are used for a different purpose. Maybe we can talk about that as a part of this today's session as well. So we have a type safety as well. Though we asked to define the types, but a variable can hold different types. Or you can say like pretty much type safety what comes with the Java, like nil reference, so null references and all these stuffs. Memory bound and everything. Maybe we can, we have few more slides later that talks about this. So this is one template which comes with the Google, Google Go program, presentation slide itself. So I just wanted to keep it as such. So each language feature should be easy to understand. Like say, let's say there is a programming language, it has a superpower feature, but it is, when it comes to a scale, and it doesn't tell you what it does actually, so it's really going to hard for you to manage. So that's how we came from the high level program, low level to high level, right? So I would suggest, like, we'll talk about this later. So history of Go is like, these guys are like from left, yeah, for you guys as well. From left, Rob Pike, and it is a Robert, and the other one is a Ken Thompson. These three guys are the founders, or known as a founders, or inventor of Go. They actually worked, are still working in Google, I guess. So their problem is different. Okay, so they usually scale. They usually code things for at a large scale. Think about Google's server farms and the Google Cloud operations and all those things. There are, we can't, just say this system is scalable or something. They really deal with all the scalable problems you can talk about any time, okay? So they wanted to, they were actually, it's an instant, on a fine day, they were actually, sitting on their desk, and they were compiling their C++ code pretty much, which is, the compilation itself happened in a distributed cluster. So think about the code, the size of the code and all those things. Okay, it took around 50 minutes or around 45 to roughly 50 minutes as per their blog. So the moment they started the compiling and they went for a talk, and it was about Google was representing the C++11's specification team and all those things. So what after the the meetup or a meeting, they came and they were discussing about what happened in the meetup and everything, and they were talking about, you're going to have introduced something cool feature in C++11, and you're going to have something that this and that and everything. So in principle, Rob Pike, and I think everyone should believe, more is not always good. So less is like less is exponentially more. That is his principle. So when I say less, ironically, Go itself has only 25 keywords, and I think it is the less type, less type, statically typed language keyword, I guess. So these guys started a conversation. Why do we really want these features in a C++? And and they wanted to get rid of the compiling time on all those things, dependency management, and they had literally in a single sentence, I would say they really hated C++. So they started the conversation, and they wanted to build something which is really scalable, and they also wanted to have it for a very clean what you can say, architecture or design and everything. These three minds has introduced all of those ideas in a thread, and that has been distributed across them in their work email in the first week itself. Most of the pretty much of Go's basic system were discussed in the mail. So those everything are available in their blog, and you can go and see what was all about and everything. So when they started, this was their questions. So again, like this is Rob Pike's slide, and why do they really want Go? So as I mentioned, they're really scaling. They were running a system which is really scalable. So think about like 10 power 7 or any machines running the same code in that scale, and every time. Okay, not just one time. It's going on every time. And they wanted to have a system or a system or a language that has a native support for concurrency. So we'll come back to the term concurrency later, but yeah, just jumping into the next slide. And not just a system scale, it is also an engineering problem as well. So think about one source tree or one single code tree has been shared across a different organizations from a different organization maybe. Different geolocations and everything. So think about how hard it is to maintain all this code and compiling and all those things. So this was their core problem, and when they started this programming language, two things was very important for them. One is the scaling in system level, and the other one is engineering level. And the Go design pretty much consist of a lot of things from different programming languages, and they also excluded some their so-called hate features. And if you are coming from Java, you probably know, as I mentioned earlier, so it is a statically typed, and of course it is garbage collected. So it has a memory safe and method interface and all those things. Maybe for time constraint, maybe I can jump. And also they left out few stuffs which they felt really don't want. Okay. So, and they added few more stuffs as well here. So programs that compile to the machine code. So there is no JVM or no virtual machine literally. So it is everything going to handle between your code and OS threads and everything. So we have a lot of basic features in Go which might really blow you when you really code at that scale. So one such is like statically linked binaries or something like that. So like something like C or C++. There is dependency handling, unlike in C++, name it any, probably, maybe I should quote NPM here. So the dependency management, it comes, you probably don't know what your package, maybe what is your package doing, and you may not know what is the dependency package doing, Probably you may know that, but you don't know what is dependencies doing. So it goes on like that, and you probably end up with having so many codes that you really don't need to do anything with your actual production or logic. So it actually comes with a lot of advantages to pick only what you want and you get started. So the binary itself going to be really minimum. So, and also, since it's being the, you can say that programmer of programming language for millenniums and all those things. So we have solutions at ground level, which is an in-house itself. Most of the solutions like built-in strings and generics and not generics, generic maps and slice, as well as built-in concurrency. So speaking of concurrency, we have to let's get a brief idea about what is built-in concurrency in Go. So this topic itself, a different talk that we can definitely do some other time later. But on a nutshell, Go's concurrency is based on a paper called Communication Sequential Process. It talks about like more of maybe I can just say this quote. It's as simple as that. It asks you to don't communicate to share the memory. It just asks you to share the memory by communicating. So literally, they implemented the same concept in communication. In Go by introducing few concepts, something called Goroutines and channels, as well as the select. So as I mentioned, we cannot get into this detail now. We'll do a different session on that later. But in a nutshell, let's say when you ask to do something with your programmers, especially in Java or somewhere else, they'll have their own style of doing. So that's why we introduce all those frameworks and everything. But still, when it comes to concurrency itself, let's say let's keep the concurrency ahead. Let's say multi-threading itself. Even though you know the concept and everything, you will be always surprised when there is a lot of memory, lock and everything happens at a larger scale. So it is really hard for you to handle, those concurrency problems, which are really which are really implicit. Okay. So as I mentioned, the programming feature of any language should be very simple to learn, right? So I would say, like, how many have read, how many have code in Ruby or Python or something? Okay, no, okay, 1, 2, some more. Yeah, I think I'm not going to get more haters. So like, especially Ruby for loop itself, like you can say just for an X, 210 or something. It's just a single line, right? It is the for loop. It does everything implicitly. But whereas Go's design itself, what emphasizes is like keep things explicit. Okay, even if it is a for I is equal to 0 and I less than 10 or I plus plus, something like that. So giving you more implicit, it doesn't going to give you a lot of advantages when it's going to for a different mindset of people and everything. So that was one of the basic design principle they wanted to keep with the Go. And as I mentioned, like, concurrency will go to we'll jump to a different slide. So this is again a concurrency talk given by Dave Pike, and again it's all everywhere in the YouTube and his blog and everything. So let's understand what is concurrency parallelism. So everyone, we spoke, right? Parallelism is like doing things at the same time. Okay, I'm waving and I'm writing. It's not concurrency. It's a parallelism. Okay, maybe. Okay, so concurrency is about doing. It's not doing. It's about handling things at the same time. So what he does define is like, let's say we have multi-core systems and networks and clouds of CPUs and lots of user, definitely. So that doesn't mean that we have we can do parallelism. When we have so much resource, we can do parallelism. It doesn't really work that way. According to his definition, programming as a composition of independently executing process is called concurrency. Okay, so what it emphasizes is like build your software in a way that it can independently executable in a parallel way. It will come later, but the way how you organize the code itself, it's what called concurrency. Okay, let's not get into much. We'll go through one by one. Probably you'll get an idea. So as I mentioned, parallelism is about simultaneous execution of any program. Okay, so concurrency, anyone want to take? Yeah, handling things in parallel, no, not in parallel, at a concurrent way. Okay, at the same time. Yeah, thanks for that. word. So doing things is parallelism, handling things is concurrency. As simple as that. Okay, let's go to the analogy. Yeah, yeah. Still we are doing, yeah, we could say. Maybe I'll give you we can go to this analogy and we'll come back whether that fits into this or not. Okay, so a better analogy is like, okay, let's say, before getting started with this example, like Gopher is a mascot of a Go programming languages. I don't know why they name so. Okay, but the name Go, it's like very precise, and all the tools can say Go C, Go tool on all. That's why they started with Gopher. I believe. So our problem is, let's say, this is an example problem we have. We have a pile of manuals, and we have a incinerator, and we have a Gopher which is running around and taking all those files into the incinerator with a cart. Okay, let's say this is a simple process. Okay, this is a problem we are trying to attack here, and how we can improve here. Okay, obviously we can add more Gophers. Okay, but definitely not with carts. We can add more cart with the Gopher as well. So now what it does, what it actually we think is like, we take two Gophers working on the same pile of files to the incinerator. Okay, so it's a simple message between them, how to do and everything. So you can double. Still we have as a problem here is like, we have a bottleneck in both the end, because they have to communicate each other to not collide. Okay, so double everything, remove the bottleneck and make them have an independent thing. They have their own piles of books, and they have their own incinerators. So it actually twice as fast as compared to the other. Okay, so this is a kind of a composition. Okay, you're doing a concurrent composition. This is also fine tuned. This is also one way of doing things faster, but definitely we have anti-patterns here, because we have a bottleneck and we did improvement, and we have given their own task of doing things. Okay, so do you think this parallel one? Yes, no, would be good. How many of are listening? Oh my God. Okay, thank you. Okay, so coming back to this story, it's very simple, and they have their own process of task to do, set of tasks to do, and they are doing. This is concurrent, I would say, but this is not parallel. Why? Because we are not, there is no guarantee that both gophers are moving at the same time. Probably one of them moving and one is idle. You get it? Okay, no. Sorry? Okay. Um, okay, assume that that's not a super gopher. It has a it has a constraint. Yeah, so the task or workflow itself, a gopher can handle only single cart. Okay, probably you can say that it can have a larger cart or something. Okay, but still that's not a parallelism. It's horizontal scaling. Sorry, it's a vertical scaling. Okay, okay, so simple. This is a composition. We have a two task, similar task, and that can be run anytime. Okay, if both are running at the same time means parallel. Okay, but we are not talking about parallelism here. We are just saying everyone has an individual job to do. Okay, everyone has an individual exam paper to answer. How do you say that both of them are writing now? That's the point. Okay, but still you have 3 hours of examination timing, and sometimes you may do parallel, but most of the time he may think and he'll be writing, and someone might be thinking on all the stuffs, right? Yeah, so we could say thread, yeah, that's what. Okay. Yeah, so we are not, that's the point. We just compose this problem into two different way, and you're still, it doesn't mean that you run one binary here and you give another binary to another computer and you run. It doesn't mean it is actually parallelism. It doesn't mean concurrency. It doesn't mean concurrent. What I'm trying to say, you break the problem itself in a concurrent module in a way that it can be run in future in a parallel way, so that it will, boost your code. So let's take this example itself. Okay, my problem was taking the pile of files to the incinerator. Okay, I have composed this program into in a way that, yeah, let's say thread. Okay, you have a runnable things, right? It's not exactly, but I'm just saying, you have a runnable composition, right? What you are giving in the run method itself, like it's a composition. Okay, you don't know whether it's going to run in parallel or in okay, yeah, so still how the system is taking and everything. But as I mentioned later, the CSP is not talking about where thread. What we are doing is like we are communicating by sharing memory. We are not the programming and this design. It's not emphasizing on that. So it will make it will make your life easy when you communicate to share memory. That's what it's all about. I'll tell you what is that communication and all those things later. So we can have also another design saying that same piles, same incinerator, we can have more gophers in between, and one still, it is still concurrency, because you are giving one gopher one job and it keep continuing to do it. Okay, but there is a still, problem, like because the one guy probably fill everything, but he has to wait to the next other guys has to come and everything. So we can add another gopher to return the empty cot itself, so that the first guy won't be ideal forever. Okay, so the thing is, it's a simple problem. We wanted to have a composition of a single unique independently runnable task, so that it can, when you have a multiple programs, when you have a multiple processor to take those jobs, you can still apply the same problem to the parallel hardwares or so-called multi-core systems, but still it is a concurrent model. So yeah, I think we should stop here, because just 1 second. Okay, with that understanding, let's assume that composition is the base core model of concurrency, whereas parallelism is about just doing things at parallel. Everyone agree with me? Okay, we'll definitely come back and have one different talk on completely on about with basic examples and all those things. Okay, so I think we are running out of time, so let's get into this. If you're starting with Go, you should first step to start is like just learn what is Go path, and if you get it right, and if you really then life will be really easy, because if just go through the Go documentation itself, nowhere else. If you get it easy, it will be much fun to start with. So because I had a lot of bad time with my Go path to learn about how it works. Probably Knox knows.
So that's the good news. If you're starting Go, especially now,
Module.
Go 1.7, you don't have to worry about Go path.
Yeah.
So it has simplified it, especially if you're starting new. And start with especially Go.11, and life will be much easier.
Yeah. Okay. So, yeah. So there is something called Go model. It will take care of all those dependency stuffs, any stuffs like that. But to get started with, this demo or whatever. I'm not going to talk about module now. Let's get started with the Go path, because probably you know the basics of what pains we had and everything. Okay. Who's this guy? Yeah, there is a famous quote by him. It's like, "Stop speaking and show me your code and everything." So with that, let's get into the hands-on session. So probably I'll go through the basic syntax of what is this Go programming language and everything. How many minutes we have? 15 minutes. Okay, we'll try to cover as much as possible for the first 15 minutes. So if you have 10 minutes and we have questions for 5 minutes, then I'll share the links. Probably you can go through where to get started and everything. Okay. So as I mentioned, let's get started with this. Yeah. So as I mentioned, there is a GoPath has 3 folders, which is actually source binary packages. Source, where actually your source code resides. And the binary is like when you compile your code, the binary will be moved there. So actually, if you add them into your Go path file, you can literally run the binary wherever you want. The package is like for handling your dependency dependent packages cache. So let's say if you have a math library, and if you want to add it for 10 times, and it can be referred from packages. Okay, so let's get started. Don't save. Okay, let me save my file here. So let's say we have a source. I already created a GeekNight, and we have something called demo.go. Okay, so let's as like other programming languages, assume that it's a more of pretty much C. So this starts with a keyword with called package, and you have to define a package called main, because that's where your actual program starts. So package main, and within that main function where your actual program starts. Okay, let's start with the famous hello world as usual. So before that, after the package, you have to import something called FMT, or whatever the package you want, like pretty much what you do in C, right? Okay, but there is a difference. I'll tell you what. Let's say I'm importing FMT and math. Okay, so this main program, and we have a println. Let's say hello geeks. Okay, I don't really want any semicolon here. What is the error? Okay, do you notice anything? What's happening here? Okay, it's gone. Okay, that's a feature of Go. Okay, so unless you use a library, or you are not just you're not allowed to just import and keep your binary bloated. Okay, as I mentioned, we have a lot of inbuilt Go tools itself. One is that itself take care of all those stuffs. Again, we have a Go tooling for a different session. So let's get started. So we have a FMT and we have a hello world, very simple program with here. And we are exactly at the location. Let's say demo.exe. Okay, we have a demo.go here. Is it visible for everyone? Okay, let's get started. So how do you compile a Go? Is like as simple as that. You can just go and issue a command called go run the file name. Okay, it just runs. Okay, but what happens behind the screen is like if you go and say go build demo.go, it does nothing in the front end, but it actually does what? It actually compiles your program, and it will take it will make it as a binary, and it will give you that in the exact same folder. When you say go and install, when you say go install, now what? It will move this demo to your actual bin folder. We have seen the source bin package, right? It actually copies this demo to your bin folder, so that you can generally say demo something. I mean, you can just issue the binary itself as a programming command CLI or something, because I don't have the path variable set for this new folder. It won't work. We have to run in this way. Okay, let's move on. So how do you declare a variable here? So it's typical. You have to start with a var and say in the variable declaration goes like this: var keyword and actual name of the variable. Then you declare the type, and you have to define it later. Okay, let's say var init value. Let's say it's an int. Okay, again it's an error. What's happening? Do you see that? You're not supposed to just declare and move away, and it takes your memory, and I think a lot of times, especially when we started without this tooling and everything, it happens a lot of the time. So it is mandatory for you to use all this value in your program, otherwise you have to clean this. Okay, hello world, what is your initial value? Now what? Yeah, it is happy and everyone is happy, and I'm going to run this. Okay, it says like my initial value is 0. Typical, like other languages, it initializes with all your variables with the default values. Even if it is a string, it is a empty string, and boolean is a false and everything. Okay, And it is always hard for me to define like long variable like this, right? Let's say now it took the 5. Okay, so there is another awesome syntax in Go. What you have to do is like just name it and give this. This is called inline definition, or declaration, or whatever it is. So it still runs. Okay, your life is very much easier when you do this. And you can say, you can second value, go and say 10. Again, it's an error because you didn't use the second value. Sorry. Okay, that's it. So it's again runs, compiles and runs, everyone is happy. Okay, so that's how the variable or type declarations comes with. Let's move forward. And there is something called, you can do cross compilation as well. So as I mentioned, like if you're running in your code in your Linux machine, you really don't need a VM to build your source code for Windows and everything. And especially if you have done embedded, you do a cross compiling from your machine to your target environment. All that you need to do is like introduce in 2 new variables, something called GoOS and GoOrg, and it does the same. Okay, now what? It actually generated something called demo.exe for your Windows machine. So anyone wondered where the demo is being picked? The name demo. Okay, I'll show you. Not just actually, it's not because of the file name, because of the folder name. So it actually runs on the package within the. If I say something else here, so yeah, now it is a file name. If I don't give anything else here, it will actually pick up from your folder name. Let's check if I'm right. Okay, it's not a main package. Okay, we'll come to that later. So we are comfortable with the variable declaration. So initial values we are clear. So the looping in Go is pretty much because you're not having so many loops to be confused. As I mentioned, hopefully no Ruby no Ruby haters other than me. So let's get started. There is only one loop in Go for. Okay, you can do with everything with that. So let's say if you want to do typical iterations, something like this. Let's say everyone listening or looking, any idea? So how many of you listening again? Hey, please pa, ரொம்ப தூரம் வந்திருக்கேன் travel பண்ணி. Okay, so there is no plus here, so it goes like this. Okay, it does the same. So what if I want to do the while loop with this? I can say I can just remove this out of this loop. Pretty much same. Okay, so we have another cool feature in loop, especially in for, since I said there is only one loop, let's say loop. And we have another feature that's called range. Before getting to that, probably we have to introduce something called arrays, or typically what we do with the arrays and everything, right? Let's say array, I'm going to start with a short notification since we have a short out of time. Let's say 1, 2, 3, 4, 5. Okay, again it doesn't. IB is equal to range from array. I means index and value means v means value. That's what I'm referring here. So let's say that works. Okay, because I is not used. Okay. Cool, right? So it actually takes the index as well as the value. So which is actually, it returns what? The range returns multiple values. Again, like it's all probably in other languages. Sorry for, I think it's in Ruby. In Python, do Ruby have this? Yeah. So as I mentioned, like Rob Pike has copied so much beautiful features except this implicit stuffs. So let's get started with the most important part of this. You can refer, as I mentioned, this programming Go takes abstract types. You can define still. It also supports functional programming. You can take a function as a first class citizen, but again we are not going to talk about this for now. But still, how do you refer another declare a function? Is a func is the keyword, and you can say square root as the function, and the variable declaration goes like that. Again, x is like a variable name, and if you want to give a, let's say square root of x is what, okay, this is what our function declaration going to be, but it has to return a value, right, so that you can get it and print. So the return value goes something like this, int again, okay. It has to return math dot, I have to import math dot rand won't have that, math dot square root, okay. It won't take integer, so we have to convert into float. Okay, everyone's cool. Let's say fmt dot println comma square root of 2. We know the value, right? So it automatically, okay. So now it does what? It returns the actual value of square root of 2, okay. But the most important feature of this, I wanted to demonstrate here is Go supports multiple return values. So what if the x is 0? So this is how it handles the errors and everything. Probably you can say here if condition saying if x is less than 0. In that case, what do you want to do? In typical Java, we throw an exception, but we can do here is like fmt dot error, or I'll do something else. Sorry. Errors dot, there is something called errors package, so that will return, give you by calling the new method of that package or interface, you can create a new error object. So to make sure you mention here, you have to declare error as well, okay. So let's say invalid input, okay. So it says what? Now what? We have to return two values, but I'm returning only one here. So let's say if it is less than 0, I'm returning 0. If it is a proper value, then I have to return an empty null value, right? Everything is fine. Why is still complaining? Body. Why? Because if we have a multiple return, we have to package like this. This guy is very unhappy because I'm capturing here and I'm not capturing both the values. Okay, so what I have to do is like I say, let's say value comma error. I'm capturing those two values, and if error is equal to nil, then I'm printing. Otherwise, what I'm gonna do? Say what is error? Actually, I have to give string. Let's say ignore this for now. Let's say okay, it does, but say it does work. Let's say if I'm giving 0, it prints nothing. Okay, because the still the value is How it's supposed to printing? Yes. Let's say minus value. Okay, it is actually not calling this part, so it actually returning here. So that's how we are actually we've seen like how it actually handled these multi-return value of a function and everything. And also there is a feature called, you don't really need to have a return and specifically define what is it. There is something called named return. When you define the variable as here itself, let's say value, and if you say y, and if you actually assign the declare these values, sorry, let's say e, and if you declare these variables here and if you assign those values, it will automatically return. So you really need not to have a return keyword there. End of this execution of this code block, whatever the values for v and e will be written here. Okay, that's one cool thing. And I'll introduce something called Go Playground, where you can start with the language basics and pretty much fundamental what you want to do with the programming to get started with Go. Okay, and there is something called type inferring and all those things. Probably, I think, do we have time? Pretty close. Okay, then we'll stop here and we'll go for questions. I think I really wanted, what I really wanted to do is like, get started with this Go, and I really wanted to have a community of people who really go code in Go. You could say like, I don't want to say like it is the feature of something and everything, but if you are pretty much in our day-to-day life, we are pretty much working with so many tools. Probably you all work with Go, Kubernetes, Docker, and what else? ED, you name anything. Okay, most of them, the awesome tools that is being used at scale today is actually running Go. Especially IoT stuffs. A lot of IoT stuffs are running Go these days. Okay, so this is specifically built for system level programming. Then it is evolved as a greater programming languages for the scale. Especially Google Cloud predominantly runs most of the service in Go. So if you end up troubleshooting something, and if you wanted to do at that scale, probably Go could help you in your career, or sometimes doing some programming language just for fun. It will make your life interesting. So I hope everyone will get started with this. Probably if you all interested, we can have the following sessions on the same. That's all pretty much. We can go for questions. Okay, again, how many people listening?
What's the disadvantage of Go? You talked about a lot of advantages, like scaling and all those things. So I'm assuming there is some disadvantage of using
I wouldn't say disadvantages. So as I mentioned, it is an opinionated language. So let's say any Go developer, if you get started, error handling was pretty hard when you get started. So in technical perspective, there are other, when you do a large programming, it's especially meant for a large scale system, a large engineering team. Maybe sometimes it will give you a hard time when you write on a single programmer. Okay, but it really works in terms of performance. Okay, so error handling one such, and probably those who are coming from Java, definitely they'll complain they don't have generics and all those things. Okay, so unlike as my personal learning was like, I learned some C and C++, then I rightly jumped into Java, and it was very native for me to get started with Java. Then I did some Python as well, but compared to Go, when I started with Go, but I was full swing, I was doing Java by then. Then when I jumped into Go development, it was really hard for me to unlearn a lot of things about a programming language and all those things. Then I have to learn what is specifically Go offers. So that was the hardest part any developer to get started. That's why I have so much theory and setting your mind, all of your mind, so it is completely different course you are doing. Anyone? Okay, so thank you so much for the opportunity. As I again, like it's I travel a lot of communities for Go conference and Go meetups. So I have a lot of minds. They are solving so many problems in Go, and I really wanted to have all of you to get started with the Go, and we could have form a community. We can make use of this platform very much. So in all of you can even we can do a workshop or something if you're all interested, a boot camp on a single day. And this Go has even a web server itself. So as I mentioned, it has the most all the requirement within the in-house itself. So you really need not to go and learn. If you want to do something in Java, you have to know Java and you have to know Hibernate or Spring and all those things, right? Still, EJB is like Enterprise EE is like still evolving, but it's not like that. You can get started in a snap with a Go. So please, give a try. So and go to playground.google playground.go.org. Okay, sorry, play.golang.org will give you this online compiling, as well as playground will give you the actual sort of a tutorial. Playground go, yeah, we can, just a second, sorry, it's called tour.golang.org will give you actual whatever we spoke here, right? It will give you all the basic syntax. If you go here, it will give you all of this topic here. You can just go and get mastered yourself. If you complete this, you are pretty much basic Go programmer. Okay, with that, I would like to thank everyone for pretending not hitting me and everything. It's really important for community and come and make an effort. And the Sungam guy, I really hats off you.
Right. Hello, guys. Hi, I'm Satish. I'm an application developer at ThoughtWorks. So yeah, today's session it's about an introduction to programming WebAssembly with Rust. It's not a case about Rust versus Golang. So I'm not also going to talk much about Rust. I'll leave that for you to explore. It's mostly about WebAssembly. So how many of you already are familiar with that term WebAssembly, or have done any WebAssembly thing? No? All right, cool. So I'll give you a brief history about what WebAssembly is. So in 2013, Mozilla started this project called AISM.js. It is a subset of JavaScript, which was to be executed as close to a native code in the browsers. So they started this project, and it was carrying out, and this is an inspiration for the WebAssembly to start. So then in about 2017 timelines, so they started this WebAssembly. They formed the baselines for the WebAssembly. So the idea is to get as close as to native code performance in a browser. Already we have the browsers have optimized the JavaScript virtual machine to an extent, but still wherever there is a need for close to native speed in the performance wise, WebAssembly you can use WebAssembly. So we are clear. Any questions so far? Cool. So it's a binary instruction format for stack-based virtual machine. Okay. So and what WebAssembly is not, it's not another transpile target for JavaScript. It's not a replacement for Flash or applets, whatever you have already used, right? So this is not going to run in another virtual environment. So it's going to run as a native code in the browsers. So right. So yeah, the architecture. So yeah, it runs on stack machines. What is stack machine? It basically you have a machine that is in a stack architecture. Instructions are pushed, and they executed one by one based on the order, right? And it supports very few data types, only the integers variants and float variants. It doesn't have much super duper data types. And there is something about the linear memory. This is the security part of the WebAssembly, where only the WebAssembly's linear memory can be accessed from the browser, the host OS, but WebAssembly program cannot access the memory outside of the linear memory. So one specific linear memory will be allocated, and WebAssembly can only access that particular memory. It can't access memory outside of that boundary. So this is the area where the security comes into picture. Right. So for any questions?
So for the linear memory, there will be a exception thrown, or how the error handling? Like if you are accessing the unauthorized memory.
You can't basically you can't access. So the boundary is only within the linear space. You can't access any other memory. That's not possible.
I thought like I'm just going to use pointers.
Mm-hmm.
I can use the address directly for the other set of the memory.
Yeah, basically you won't be able to point to external memory. We will get into the areas. So why Rust for WebAssembly? Basically, Rust is an awesome language. But that's not the main reason, right? So Rust is also started as a Mozilla project. So they have a fantastic tooling and support for WebAssembly. So when they started WebAssembly, they started creating all the required tools in Rust from the beginning itself. So it has fantastic first-class support, and they also have a separate working group in Rust community. So apart from that, what other language features that makes it perfect for WebAssembly? So let's quickly see about what Rust is, right? So it's like Go. It's a system programming language. One major difference between Go is it doesn't have a garbage collection. So how it handles without having a garbage collection, right? So all the memory management of allocating, deallocating, everything is done through done at the compile time itself. So basically, Rust has the concept of lifetimes, and it knows when a variable goes out of scope. So when it goes out of scope, it automatically adds an deallocation statement. So all the memory management stuff happens during the compile time itself. That's one feature. So this gives us the guarantee about all the memory related errors. So all the memory related errors goes out in Rust, right? And there are few other language level features, very high level, like ownership and borrowing. So ownership and borrowing helps in concurrency related problems, like how Go uses channels. Channels are also there in Rust. There are also mutex. There are different way in which you can use the concurrency. And also it has generics. So everything another benefit about Rust is everything is zero cost. So what I mean by zero cost is, for example, why Go didn't have generics at the start, right? So in Java, why do we have generics? It adds more runtime complexity. So all the generics or any function calls, so they all take more runtime. In Rust, so all these abstractions are zero cost. Basically, when it compiles down to a binary code, all these overheads are taken away. So and another thing is Rust ecosystem. Like Go, there are awesome tools like RustHub to manage the Rust versions, and there is Cargo, which is like Go's build tool, management, dependency management, and everything. All right, so if you want to learn about Rust, I think there is the Rust book. This is a very well documented official Rust book that you can go. So it has all the fundamental the concepts about the Rust and all the language features. I'm not going to go through each individual features. So let's go to the WebAssembly, right? So again, I'm going to refer the examples from another book, Rust WebAssembly book. Again, so in Rust community, right, all of these documentations, they have done it to a perfect level, right? So they have a book for each of these concepts. So Rust basically they have different working groups for each major area, like networking. There is one working group for WebAssembly. There is one working group for embedded systems. So all these books they have properly created these books, and you can refer them. Right. So far, any question before I dive into the demo? Okay, so what are we going to do now is creating a REST project, converting it into a WebAssembly binary, and trying to import it into a JavaScript web application, and trying to load it in the browser, right? So I have done most of the setups like installing REST, installing Wasm pack, also the cargo generate. So I'm going to straight away generate this. So let's name this project as 5. Okay. Let's look at what it has generated, right? So this is basically a template generator. So it takes a particular project and it creates a template. So let's see what are the files that are available. So the syntaxes of Rust will be mostly close to C or C++, because it is it's targeting mostly system programmers. Those are coming from C and C++ background. So don't worry about the syntaxes if you are not familiar with. We'll just look at the core things that we are trying to do here, right? So we are creating a library in Rust. So libraries will have this lib file naming convention, and if you are creating a main program, it will be main.rs, right? And we are trying to create a greet function which is going to alert and say hello world or whatever, right? So this annotation, this is the annotation syntax in Rust. So this is going to create a Wasm bind, right? So this is another external method that we are going to use it in our program. So this is basically a method from Wasm bindgen, and we are going to use it. Forget about this. You don't need to worry about it now. Right. So let's build the project, right? So I have already installed Wasm pack crate. So I'm just going to build. So while building, it's going to convert this Rust code into a binary, Wasm binary. So there are two different Wasm formats. One is text format and another one is binary format. Text format is mostly for our understanding to read, and the binary format will be imported in browser. So yeah, it has compiled. So now it has created a new directory called package. So anything is familiar in this structure, in this package? Cool, package.json. So what it has done is it has compiled this Rust code into an npm module, node module, right? It has created also a JavaScript file and also a TypeScript if you are using TypeScript. And it has also another special file. So this is going to be the binary, Wasm binary that we have created. Right? Anything, any questions so far? Cool. Yeah, in this so this is a binary format. We can't read about this, and So the TypeScript is just going to give you a header kind of this thing to avoid any type errors. All right, let's try to create a web project and use this npm module in the web project, right? So theoretically, you can run WebAssembly in any WebAssembly executor, but here we are using the browser to execute it. So for that, we need to use JavaScript to include the binary. So actually, in the WebAssembly community, in Rust WebAssembly community, they are also targeting to make it as a runnable code in any environment, right? So it's not specific to browser, but now it's predominantly web, right?
But Rust by itself, you can run it natively on server side. As Satish was saying, it also targets microcontrollers. That's the other end of the spectrum. And this is the browser's, this is how it reaches to the browser through WebAssembly.
Right. So yeah, so now this is Google Chrome. I'm not using Firefox. So yeah. One more interesting fact about Rust is it was mainly created to avoid all these concurrency issues, right? So mostly Firefox was written in C++ with a lot of parallel thread, multi-thread code. And they created a safe language which will avoid all these concurrency issue, memory issue. So then they created this a new engine. What is the name of the engine? The latest engine that runs Firefox is written in Rust. Cool. So now we have created another template. Let's take it look at the template. So yeah, www, I have created test www inside the same directory. Yeah, server. Thank you. Cool. Let's look at the generated template, right? So this simply includes bootstrap.js. This is another wrapper around index.js. And in index.js, we are trying to include Wasm from Hello Wasm Pack. We'll have to rename it. We have named it as different. I think it's Game of Life Wasm. And it's trying to call a greet function from that. So yeah, before that we'll have to also install all the dependencies that are required for this node project. And to use our locally generated npm module, we'll have to first link it with npm. And to link it within the newly created node project, you'll have to go there and do a link. Okay, it's linked now. Let's try to change the name of the package. And let's start serving it. Okay, it's saying hello. So we have a npm package that is created in our local. So it's going to link it so that the installer will, the npm module will automatically get added to the newly created node project. Right. Okay. So, oh yeah, before that, I think I didn't build it. Yeah. So I have another versions of this code. Let me open that. So yeah, I have made some changes in the existing code. Added a new parameter to the greet method, getting a name and trying to print it from the Rust code. So let's start this code and stop it. So this is already running. Okay, it's running on 81. So yeah, it says hello Satish. Not very fancy, right? So let's try to implement the game. So I don't know how many of you already familiar with the problem game of life. It used to be interview question for quite some time. Yeah, for that. So yeah, if you had tried before, you would have known. So yeah, quickly about the game of life. It's about a universe. It has a bunch of rules. So each cell's life next cycle will be dependent on the surrounding cells, right? So there are a bunch of rules. Basically, the entire universe gets recreated at every tick, depending on the surrounding cells, whether they are alive or dead. And it can form interesting patterns like shown here, right? So let's try to implement this. So I have already taken this code and created another version of this code. So I'll have to build again the awesome code. I'll have to build again, and let me restart it just to be sure. Cool. So what happens in the background is, let's go through the code, right? Let's go from the index.js. So the code is more or less the same. So we are trying to import the universe from the WASM binary, and we have also created a new element in our HTML file. And in that new element, we are trying to render the entire universe that is coming from the Rust code, right? So basically, all the every tick and the computation of the next state of the universe is happening in Rust code. We are simply getting the content from the code and just rendering it. Okay. So let's look at the Rust code. So we have a cell, it's a enum. It can be either dead or alive. And we have universe, it's a vector of cells. It has a height and width. And so for each tick, So for each tick, it's going to check few rules and set the next cell's state. It's pretty straightforward code. All right, so this is the first version of the code. So far, any questions? All right, cool. So in this, we get all the output from the WebAssembly binary, and we are just rendering it in JavaScript, right? What about getting the data as an array, the state as a binary array, and then doing the render in JavaScript? Let's try to do that, right? Okay, so I have also changed some parameters, like increasing the number of cells. Now it renders about 2000 pixels or 2000 cells. Earlier it was rendering about 200. Now I have increased it to 1200, 2200. So what happens in the background, right? Let's check. So there is one more import of memory. So this is directly getting the linear memory that we talked, right? So directly getting the linear memory from the WASM binary into our JavaScript and trying to access the memory directly in JavaScript. Right? So let's see how we are accessing the memory. So we are taking the memories buffer, and the cells pointer is from the cells universe. Basically, the memory buffer, linear memory buffer is there, and we also need a pointer in that buffer, right? Which pointer to access to. So we are passing those two information and creating an array in JavaScript, and using this array to do all the rendering.
This memory is like a native memory, or the memory constructed by WASM, but it's still within the JavaScript runtime.
It's native memory, but from WASM you can't access anything apart from that allocated linear memory. It can grow in number of whatever space you're trying to access, but it can't access beyond that linear memory. But that memory is accessible for the host. Here the host is our JavaScript environment, so that can access. It's still in the VM, but okay, yeah, I think it's, yeah, it can't be. Cool. So we were trying to do the similar exercise in JavaScript and trying to see the comparison of both, which is not there in the book, by the way. So it's a different directory. Okay. Yeah, this is pure JS. It's the code is more or less same. I just copied the Rust code and changed it as a JavaScript code. So you can see, so the frame per second is also displaying here. So you can see the frame per second is almost double as JavaScript implementation. Mostly the computation is happening almost twice as fast as JavaScript. Sorry. I didn't get the question. Come on. So yeah, the rendering is it's the same. The code is same. So let me show you the code as well. So there is this array, right? The array creation, once the array is created, the rendering is same, right? So only that part is different between these two implementations. Yes, basically you are getting close to native performance. That's the idea. So what does it mean? So do you throw away all your JavaScript and write in Wasm? No, that's not gonna happen, right? So and not all the applications are that CPU intensive. So the idea is wherever there is an application where you need more CPU intensive work to be done at the browser, you create those modules alone in Wasm and create an npm module and try to import it in your already existing JavaScript environment, right? So it's there to coexist with JavaScript and not to replace JavaScript. That's the idea. Any questions so far? Yes, we are nearing the end of the session. In Rust, yes. Okay. I'm not really sure. You can still debug at the JavaScript layer, and you can do the rest of the test in Rust. Rust has best, I mean, out of the box testing inbuilt with the language core language itself. So yeah, once you have done the testing at that level, you may not need it. Yeah, so the Wasm text format, if it is already there, maybe I haven't tried, maybe you will be able to do the debugging. Yeah, some. Sorry. Mm-hmm. Yeah, so in the other example I was showing, right, you can pass a name and get that printed. You can pass string or integer. That's possible. Yeah, I was going to say, so WebAssembly currently is like a single-threaded, or you can't do parallel processing. So, but in the future spec, I think they're going to include concurrency as well. But once that is out, Rust's use case will get even more strong, right? So since Rust has a very strong concurrency and the thread safe code, yeah.
So what happens today if you use coroutines inside Rust?
So basically, you are doing the wasm gen, right? So let me open that. So this wasm bind gen, this annotation will check which target you are trying to compile it for, and it will avoid. Yeah. Everything in Rust is a compilation error. So the first few weeks or few months, you'll get tired of getting the compilation error, but once you get used to it, you'll see the value. Obviously. well, both.
While you're saying that most of the obvious issues will be caught in Python,
Right. Non-obvious errors as well, right? So for example, okay, I'll do a quick comparison between Rust and Go, right? So there are few semantics that Go lacks, like send keyword. For example, in Rust you can send an object to a different thread, which will again provide the thread safety, which Go currently doesn't have, and generics obviously, and there are quite a few high level functionalities, high level language features that Go lacks, which Rust has. But Rust's where it Go overtakes Rust is in the native async support. Currently they are trying to include that to Rust as well. So once that comes into the stable version, it's already nightly. Once it comes to stable version, I think Rust and Go are like yeah, in same level. Yeah. Go is like a very old language compared to Rust, right? Rust is the first stable version released in 2014. I think Go goes beyond like a 10-year language. Yeah. Cool. That's all I had. So there are a lot of good materials out there. If you are interested, go check out the Rust book for sure. So it explains all the functionalities with great resource. So and so each different working group has this different book. For Wasm they have one book, and they have also one for embedded. Yeah, go check out. Cool. Thank you.
Just want to thank each and every of you for coming out and grow this community. Also thanks to Karthikeyan and Satish for the valuable learning that you've shared with us. Before we wrap up, we'd like to get your feedback. So if you have this your camera or just type up this URL. So I'm a recent joining in ThoughtWorks, and one thing I've learned from talking here is that we take feedback extremely seriously. So I know previously someone asked me to take feedback, I said, yeah, whatever, I'll do later. But after joining here, that I've learned the importance of giving effective feedback and how like people really grow themselves based on feedback. So we really value your feedback. We would really if you could just fill out the feedback.